All right, let me give you an example of something that would be a quadratic function. Instead of using a, b, and c, I'm going to use numbers like y equals 2x squared plus 5x minus 4. Each of these numbers determines something about the way our graph is going to look, and they're all helpful for when the graph of the parent function shifts to the left or the right or up or down. I've put colored pencils in the basket on your table. If you're a visual learner, you might want to grab one because I think it'll help you to mark on this standard form what each of these spots helps you do. This spot, if there's a number that comes before the x squared, that spot is going to tell you if your parabola opens up or down. It's also going to determine how wide or how narrow the parabola is. So it determines wide or narrow. And I'll talk about why that happens when we do an example. The number at the end, the constant term, the one that doesn't have an x value, that one's super helpful. It's going to be just like a linear equation. If you'll remember, if you had a linear equation like y equals 2x plus 3, this number tells you the y-intercept. The same thing is going to happen on a quadratic function. The constant term is going to tell you where your graph crosses the y-axis. So it's going to tell you the y-intercept. The middle term is going to help you find the vertex. And I'll explain how that works in just a moment. Helps find the vertex. So before I do example 1, let me tell you the formula for finding the vertex. And I'm pretty sure you talked about this in Algebra 1. But to find the x value of the vertex, x equals negative b over 2a. And when I talk about negative b, b will always be the number that comes in front of the x to the first power. A will always be the number that comes in front of, or the coefficient in front of, the x squared term. To find the axis of symmetry, it's always just going to be x equals whatever the x value of your vertex. And this will make more sense as we do an example.